Okay, so starting our unit today, rational expressions. Rational just means, in layman's terms, it means fraction, okay? Technically, it means something that can be expressed in the form A over B, where A and B are rational. That's what it means for numbers. But when we talk about rational expressions, we're talking about two expressions that can be P of X over Q of X, where P and Q are polynomials. So we've just spent a good part of 2 months dealing with polynomials. Now we're going to talk about what happens when you divide two polynomials. You no longer have a polynomial, you have a rational expression. So for example, if I look at this first example here, those are both polynomials. You've got a third degree polynomial in the numerator, you have a second degree polynomial in the denominator. When you write them like this, you no longer have a polynomial, you have a rational expression because you have a polynomial divided by a polynomial. So each of the examples of what you see here are examples of rational expressions. Okay? So, things we do with rational expressions. We're going to spend some time multiplying them, dividing them, adding them, subtracting them, simplifying them. And that should get us a long way to what we want to accomplish here. So, as an abbreviation or get started, how would I simplify something that looked like 24 over 36? Okay, this is not a rational expression. This is a rational number because it's expressed as the quotient of two integers. How do I simplify this? Just tell me, what do I typically do? Least common denominator, least common factor, okay? So, and there's also the least multiple. So I need to factor it. So if I can write this as 24, so remember how I did this before. I would say 24, divide that by 2 and I get 12. Divide that by 2 and I get 6. Divide that by 2 and I get 3. Okay? So this is what? This is 2 times 2 times 2 times 3. Okay? That's as simple as I can write it. Okay? 36. If I look at 36, if I divide that by 2, I get 18. Divide by 2, I get 9. Divide by 3, and I get a 3. So this is 2 times 2 times 3 times 3. Now, what I'm trying not to say for the rest of the year here, I'm not trying to say cancels out, okay? The mistake that people make in rational expression is they get cancel happy when they just start canceling things, okay? What I would rather say is, if I look at this, what is 2 divided by 2? Okay, that is 1, okay? 2 divided by 2, that is 1. 2 divided by 2, what is that? Oh, excuse me, 3 divided by 3 is 1. So this is 1, 1, 1. What am I left with? 2/3. So this answer is 2/3. Now you may have learned, oh, the 2 over 2 cancels. Technically, they do cancel. But mathematically, it's more precise to say 2 divided by 2, that evaluates to 1. So I'm not going to use all those words. But what I'm trying to avoid is there'll be situations where people do something like, let me do an example. If people do something like, something like this, x plus 1 over x plus 2. You cannot do that, okay? You can't just cancel out the x's, okay? What you have to do, everything has to be in factored form, and then you look at each of your factors, okay? So this is why I'm trying not to say, oh, the 2's cancel, okay? I'm trying to say, if it's fully factored, okay, then I can say, okay, now I can evaluate this factor divided by this factor as 1, okay? Because what I'm trying to avoid, if I had something like 2 plus 3 over 2, that number is 5/2, right? What would happen if I said, oh, these cancel and that's 3? That's wrong, okay? So this is 5 over 2, that's 5/2. Or you could write it as, 2 over 2 plus 3 over 2, and that is 5/2, either way. Okay, so what I'm going to try to do, I'm going to try to be very conscious about not saying these things cancel, okay, because that's one of the biggest mistakes people make in this particular unit is canceling things that really don't. So how do we simplify rational expressions? there are multiple ways of doing this. I can multiply everything out and then simplify, or I can try to write things as products of factors and see if things are simplified earlier on. So if I look at what is 5, 5 is just 5 times 1, x squared y cubed over 3 xy to the 4th. How can I write 27? How do I write its product of its factors? That's what, 3 times 3 times 3, right? So this is, that's 27. What about 15? This is not algebra, this is arithmetic. How do I factor 15? 3 times 5. 3 times 5, x to the 4th y, okay? Now to simplify things, it looks like, what is 3 divided by 3? That is 1, right? 5 divided by 5, that's 1, okay? 3 divided by 3 over here, that's what? That's 1, okay? So what am I left with in the numbers? I'm left with a 3 in the numerator, okay? And then I've got what? X squared, y cubed, x to the 5th, over x, y to the 4th, x to the 4th y. We had a unit on exponents already. What is x squared times x to the 5th? X to the what? I'm not hearing it, and I do have trouble hearing, but did I hear 7? X to the 7th, y cubed. What is x times x to the 4th? X to the 5th. What is y to the 4th times y? Y to the 5th, okay? And then how do I simplify this? Yeah, this is 3 x to the, what, 7 minus 5, and y to the 3 minus 5. So this is 3 times x to what power? X squared, y to the negative 2. So we write this as 3x squared over y squared. Okay? So we've done this before, okay, with exponents. So when we get things down to the factors, when things are fully factored, that's when I can simplify, okay? And you see the simplification here. There were multiple things that in the numerator, also in the denominator, that when I divide, they turned out to be 1. Now, the other thing that we've got to be careful about is with rational expressions is in math, you can never divide by what? 0. So there is an exclusion, this expression. Y can never be equal to what? Y can never be 0 in that expression. If y were 0 in that expression, I would be dividing by 0. Now, look at the original problem here. What would happen if x were 0? Would I be dividing by 0 in the original problem? Yeah. What if x were 0 here? Would I be dividing by 0 in the final solution? No. So something happened along the way. So we've got to pay attention to our original problem and then our final solution. We'll talk a little bit about that as we go along here. So let's talk about exclusions when we see a problem, okay? The exclusion is I cannot divide by 0. Question, yes. Okay, the exclusion is we can never divide by 0. So when I look at a rational expression, what would cause me to divide by 0? Okay, in this, what would cause me to divide by 0 when x plus 1 is equal to what? 0. So in this case, x plus 1 cannot be 0. That would make this expression undefined. So x cannot be what? Negative 1, okay? So this is my exclusion. X cannot be negative 1 in this expression. This expression is undefined if x is negative 1, okay? Look at the next one. Basically, I'm always looking at the denominator. In this case, x cannot be what? It can't be -1, and x cannot be what? -2. Those are the two exclusions for this rational expression. Now, in order to determine our exclusions, I need everything to be fully factored, okay? What is the denominator in this next one? X squared minus 9. Is that fully factored? No. How does that factor? That's x plus 3, x minus 3. What are the exclusions? What can x not be? Yeah, so x cannot be 3 or -3. What's the exclusion in the last one? X cannot be what? Yeah, 0. So to find the exclusions, you're always looking for where the denominator is 0. We can never divide by 0. Now, there's going to be a little bit of difference of what happens in the original problem versus our final solution. And we'll talk about that as we go on today. Let's look at something like this. X squared plus x divided by x plus 1. Now, what you've got to be very good at in this unit, besides the arithmetic and not making careless mistakes, you got to be very good at factoring, okay? So you have to look at every rational expression and say, is it factored? I've got a numerator and a denominator. Can I factor that denominator any more than what it is? X plus 1. No. What about this? Can I factor this? The numerator. Yeah, what do they have in common? They both have an x in common. So this is x times x plus 1 divided by x plus 1. Now I've got the numerator fully factored, the denominator fully factored. Now I can look and see if it simplifies. Can you see any simplification there? This would be where the teacher asks the question, the students respond with an answer. Can you see anything that can be simplified? Yes. What is x plus 1 divided by x plus 1? That is 1. So what am I left with? X, okay? So this rational expression, it looks a lot like, and it behaves graphically like f of x equal x. What's the graph of y equal x? It's here. What is the graph of y equal x? It's a straight line, right? Okay. So that's what this function looks like. It looks like a straight line, but there is one little gotcha with this. When I look at this original problem, what's the exclusion that I see? X cannot be what? Yeah, so when I look at this, x cannot be -1. This whole expression is undefined at -1. So even though my final answer is x, graphically this problem is going to behave like x, but it is undefined at -1. So you see this open circle here. Okay, so the domain of this function, what's the domain of this function? Somebody help me read the domain of this function. Interval notation. -infinity to, no, -infinity to -1, -1 to infinity. X cannot be -1, okay? So what we will say in this case is, if you look at it, there is a, and this is not really great math, but it's just sort of a colloquialism, there is a hole in the graph at x equal -1. So there is an exclusion. X cannot be -1, okay? But what happens is when I look at the simplification, there is no exclusion to this. Y equal x, that's a straight line. But my original problem, I cannot plug -1 into that problem because I get something that's undefined. So if I look at the domain of this function, it's every number except -1. So -1 is my exclusion. Okay, we're not going to do a whole lot of graphing, but here's the key, is when you see something, when you get in factored form, then you look and say, what is my exclusion? This has an exclusion at -1. Okay, then you're going to need to look at your final answer. If the final answer has no exclusions, then you'll say, well, that exclusion that I had is it's simply a hole in the graph, it's a hole in the domain, so I cannot have it as part of my domain. Okay, now that's a little bit different than this problem here. This has the same exclusion. X cannot be what? X cannot be -1. But when I graph this function, I get something a little bit different, because if I look at it, this is the function f of x equal 1 over x plus 1. So my final answer still has the same exclusion in it. This final answer had no exclusion. This one does. Now, if you graph this function, it's undefined at -1, so you see an asymptote. So if my final answer has an exclusion, that's going to be a vertical asymptote. Question, Jack? An asymptote it's a vertical line here which the graph cannot cross. The graph is undefined at -1, okay? So there is no solution here at -1. Now, when you get to pre-calc, you're going to spend a lot more time graphing these functions than we are here. So we're really not going to spend a lot of time graphing. We're going to spend time working with and simplifying. So here's the procedure of what you need to do with rational expressions. I think it follows here. You're going to look at the original of every expression, okay? And you look at where the denominator is 0. That will give you what you call an exclusion. It's where the graph is undefined. That's your exclusion, okay? It's a generic term, where the denominator is 0. If in the course of simplifying that exclusion went away, we'll just say that that remains a hole in the graph, a place where the graph is undefined. If in my final answer that exclusion is still around, I'm going to call that a vertical asymptote, okay? So we'll look at the beginning of the problem to define our exclusions. By the time I get to the end of the problem, if that exclusion factored out, we'll call that a hole in the graph. If it's still there, it's a vertical asymptote. So let's look at how we simplify expressions. Look at the first one you see there, okay? Can you look at this and tell me what the exclusions are just by looking at it? Unless you're really, really good, the answer is probably no. The first step, if I look at step 1, I would probably need to do what? Factor this completely, okay? What are these things? What do you see on top? This is called a what? A quadratic. Do we know how to factor quadratics? Yes. On the bottom, you see a quadratic, okay? So I need to factor these two things completely, okay? Yes. If you divide by 0 is undefined. You can never divide by 0. Okay? So let's factor the numerator. So I need to find two numbers that do what? Yeah, multiply to 16 and add to -8. What numbers do that? -4 and -4. Okay? And then I also need to find two numbers that multiply to -24 and add to 2. What numbers do that? How about a 6 and a -4? Okay? So I can factor the numerator as what? X minus 4, x minus 4. What's the factorization of the denominator? X plus 6 over x minus 4. Okay? Now, before I do anything else, I can list my exclusions. My exclusions are where the denominator is what? The exclusions are where the denominator is 0. Okay? So what are my exclusions in this problem? X cannot be what? -6 or +4. Okay? Because either of those two numbers would make this whole expression divide by 0, which is undefined. Now I want to simplify like terms, okay? What is x minus 4 divided by x minus 4? What is that? X minus 4 divided by x minus 1. That is 1, okay? So I'm left with what? X minus 4 over x plus 6, okay? That is the simplification, okay? So now what I want to look at, these were my original exclusions, okay? Now, what's the exclusion here in the final answer? X cannot be what? -6, okay? So the exclusions we have, -6 and 4, okay? Which one went away in the course of simplifying? 4 went away, okay? In the final answer, 4 is not an exclusion. So if in the course of simplifying, that exclusion goes away, we call that a hole in the graph. So x equal 4 is a hole in the graph. You look at your final answer. Any exclusion that remains is a vertical asymptote. What's the exclusion that you see here? X cannot be what? -6, okay? So in your original problem, you have exclusions where the denominator is 0. If the exclusion is still there at the final answer, that's a vertical asymptote. If that exclusion went away in the process of you simplifying, we simply call that a hole in the graph. Yes, Jack? No. So if you're setting them equal to 0 to find their roots, then yes. But in the factoring, no. Okay? I mean, if you look at this, multiply that, you get x squared minus 8x plus 16. Okay? X squared, 6x minus 4x, that's 2x. 6 times -4 is -24. Question? Okay, let's look at another example. Okay? To list exclusions, and before I can list exclusions, everything needs to be in fully what form? Factored form, okay? So, look at the numerator. Can it be factored? Answer is yes. How do I factor the numerator? You factor out what, a 2x? So that's 2x times what? X plus 5. Okay, that is the numerator, okay? Now I need to factor the denominator. I'm going to come over here and use some space. 3x squared plus 16x plus 5. So if this can factor, I need two numbers that do what? Yeah, multiply to 15 and add to 16. What numbers do that? Yeah, 1 and 15. Okay. So now I'm going to rewrite this as 3x squared plus x plus 15x plus 5, so that I can now factor this by what method? Grouping. What do I have in common of the first two terms? X. What do I have in common with the next two terms? 5. So this is what? X plus 5, 3x plus 1. So this is x plus 5 3x plus 1. Now I'm fully factored. What are my exclusions? Okay, the exclusions come when the denominator is 0. So x cannot be what? -5, and what else? Yeah, -1/3. Okay, those are my two exclusions. Either of those numbers would cause me to divide by 0. Now I simplify terms. Can this be simplified? What is x plus 5 over x plus 5? That's 1. So what's the final answer here? 2x over 3x plus 1. Okay. So if I look at this final answer, what is the exclusion in the final answer? Yeah, so that is my vertical asymptote. X cannot be -1/3, and the hole in the graph. So excuse me, let me back up and rewrite this a little bit different. The exclusion is x can't be -1/3. So there is a vertical asymptote at x equal -1/3. That is a vertical asymptote. What is the hole that's in the graph? Yeah, the first one was, what was it? -5. So x equal -5 is a hole in the graph. Okay? So is everyone clear? The exclusions are where the original problem would cause me to have something undefined, dividing by 0. If that is still in the final answer, that exclusion is a vertical asymptote. If that answer went away in the course of simplifying, that just remains a hole in the graph where the domain is undefined. Question? Yeah, so let me back up. I think I did it a little bit different on this one. The vertical asymptote is actually, it's where x equal -6, and the hole in the graph here is where x equal 4 is a hole in the graph. Okay, the exclusions are that x cannot be these numbers. That makes my problem undefined. When I get to the final answer, x cannot be -6, so I've got an asymptote at x equal -6, a place where the graph is undefined. And I've simply just got a hole in the graph or exclusion at x equal 4. Okay. Okay, let's look at the next one here. Now, before I do anything, the key to getting everything done is to be able to do what? Factor. You've got to be able to factor. You've got to be able to look at this and say, what can be simplified? So I've got what's different here is I don't have one fraction, I got a fraction times a fraction. You're going to have to be able to simplify everything. So look at the first numerator. What can be factored there in the first one? 5x, right? So this is 5x times what? 4 minus x, right? Everyone see that? Okay. What about in the denominator? This is what? X times x minus 1. Now look over to the next one. This can be factored if there are two numbers that do what? Multiply to -4 and add to +3. What numbers do that? 4 and -1. So this is x plus 4, x minus 1. And then look at that last one there. That's what? What's our factoring method? That's the what? Difference of two squares. How does this factor? Yeah, x minus 4, x plus 4. Okay. Now, if this were the first, one of the previous tests on polynomials, these are 4 different factoring problems. They're now all rolled into one. So you can see factoring is very important. If you miss any of these, you're going to get the whole thing wrong. So you got to be very careful. You got to be very confident about factoring everything and staying organized here. Okay. So what are my exclusions? X cannot be what? What is this? What is the exclusion here? X cannot be, I'm looking at this one, 0. X cannot be 1. X cannot be 4 or -4. So X cannot be 0, 1, 4, or -4. Okay. Now, I've got it in fully factored form. Let's go ahead and see what we can simplify. What is x plus 4 divided by x plus 4? That is 1. Okay. What is x minus 1 divided by x minus 1? That is 1. What about x divided by x? That's 1. Okay. So what am I left with? I'm left with 5 times 4 minus x over x minus 4. Is that as simple as that gets? Yes or no? You can go a little bit further. I want you to write it this way. What about if I write it this way? Everyone see how I did that? What did I do? I factored out a what? A negative. Okay, so this is, if you multiply, this is what? 20 minus 5x, right? 20 minus 5x. This is what? 20 minus 5x, okay? Now what simplifies? What's x minus 4 divided by x minus 4? So this answer is what? That's negative 5. Okay, so this big expression times this expression equals negative 5. Okay, so are there any vertical asymptotes? Are there any exclusions here? No. So these exclusions are called what? Holes in the graph. Okay, so the holes in the graph are at x equals 0, 1, 4, negative 4, and there are no vertical asymptote. So 4 minus x is the same thing as negative of x minus 4. Factor out a negative 1. Okay. Okay, so if I put a negative in front of this, instead of this being 4 minus x, it's x minus 4. I mean, the other way of seeing this is you've got 4 minus x. I'm going to multiply this by negative 1. What's negative 1 times negative 1? 1. So this is all the same thing, right? Okay, all you want to do is just distribute this one. So this is negative 1 times negative 4 plus x. That's negative 1 times x minus 4. And let me skip this one for now, because now I want to get to, let me do the division, the ones that are division here toward the end. Now, going back to middle school, dividing by the fraction is the same as multiplying by its reciprocal. Okay, we don't like division. I'm going to turn this division problem into a what? Multiplication. So what I will do, so I don't get mixed up, let me just change this problem from the very beginning, and let's just rewrite this problem as a multiplication. Everyone agree with that? Now I've got a multiplication problem. So the division problems are really not much more difficult than multiplication, because the first thing you do is change it to multiplication. And now we're going to do the same things we did before. To find the exclusions, I need to get everything in fully what form? Fully factored, okay? So looking at the numerator here, what numbers multiply to negative 21 and add to negative 4? That's a what? 7 and minus 3, right? So this is x plus 7, x minus 3. The denominator, how do I factor that denominator? 5 times what? Yeah, x plus 3. Okay, then I move on to the next fraction. What am I seeing in the numerator there? That's what method? Difference of squares. So what is that? X minus 10, x plus 10. Now I look at that numerator, excuse me, the denominator. This one I may need to write down. What are the two numbers that multiply to negative 70 and add to positive 3? It's what, 10 and 7, positive 10, negative 7. So this is x plus 10, x minus 7. Now, at this point, I changed it to multiplication. It's fully factored. Now tell me all the exclusions, okay? So what are the exclusions? X cannot be what? Negative 3, and what else? Yeah, negative 10, and positive 7. Now, someone tell me, why didn't I do the exclusions when it was a division sign? Why did I change it to multiplication? Why did I wait to do that? Yeah. Well, if you look about it, so when I'm dividing by this, when I change it to multiplication, it flips, okay? So when you look at this, you might say, oh, it's okay if this denominator was, excuse me, if the numerator was 0. But what happens, I flip it, that numerator becomes the what? Denominator, and that's where my exclusions are. So what you want to do is before you do your exclusions, make the problem a multiplication. Then go look at the denominator to determine what the exclusions are. Okay? Now, is there any simplification? So what is x plus 10 over x plus 10, right? And that's it, right? Did I do a mistake? Oh, you're right. This was x minus 7 and x plus 3. Okay? So is there any other simplification then? X minus 7 over x minus 7, that's 1. X plus 3 over x plus 3, that's 1. So what is this final answer? X minus 10 over 5. Okay? So are there any vertical asymptotes? Basically, you look at this. Are there any exclusions here? No. Your denominator is 5. That will never be 0. So this one has no vertical asymptotes. So all of these exclusions are what? They're simply just holes in the graph or the domain. They're just places where this function is not defined, okay? But you can't tell by looking at the final answer. You could tell that by looking up here at the original, okay? So let's look at this example. I've got 3x squared plus 13x minus 10 over 6x squared divided by 3x squared minus 2x, okay? So I'm dividing by, it may help you to do this, okay? I need to change this division to a what? Multiplication. So by changing this to a multiplication problem, it's 3x squared plus 13x minus 10 over 6x squared times what? 1 over 3x squared minus 2x. Okay, so now I've changed the division to a multiplication. Before I can find the exclusions, I'm required to do what? Factor it completely. Okay, so to factor this guy completely, let's look at that 3x squared plus 13x minus 10. I need to find two numbers that multiply to what? Negative 30 and add to 13. Are there numbers that do that? Yeah, so that's a 2 and a 15, and if the 2 is negative, those multiply to negative 30 and they add to 13. So this is what? 3x squared minus 2x plus 15x minus 10. Factor by grouping. This is what? X, 3x minus 2 plus, and then I factor out what? A 5, 3x minus 2. So this is x plus 5, 3x minus 2. That's just factoring one of the numerators, okay? These problems, the gripe about these problems with students is what? They're long, okay? So that tells me that this first thing is what? X plus 5 over 3x minus 2 divided by 6x squared. How do I factor that thing, the next one there? What do they have in common? 3x squared minus 2x. X. And you're left with what? 3x. So, sorry, it's right here. So it's times 1 over, and that's what x, 3x minus 2. Okay. Now, before I cancel anything out, and I don't want to say the word cancel, before I simplify, what are my exclusions? Okay. So before I simplify, what are my exclusions? What would make me divide by 0 when x is what? 0 or what else? Come on, guys. Yeah, no, it's 0 and 2/3. Do you see that? X cannot be 0 and x cannot be 2/3. Okay. We had a lot of practice with that. The polynomials trying to find roots. Okay. Setting these factors equal to 0. So those are my exclusions. Okay. Now, when I start to simplify, what is 3x minus 2 divided by 3x minus 2? That is 1. So this is x plus 5 over 6x to what power? Cube. Okay. So what is the vertical asymptote? X equals 0. You look at your final answer, your exclusion is 0. So x equals 0. That is a vertical asymptote. And the hole in the graph would be anything that went away, which was what? X equal 2/3. Okay, so here's the process. Again, here's what we always do. Fully factor it, okay? And then you look at your denominator. Anywhere the denominator is 0, that is an exclusion. Think of exclusion, that's a generic word, like shoe, okay? What's a brand of shoe? That's a very specific one. So like the generic word is an exclusion, where the denominator is 0. Then simplify. If your final answer has an exclusion, that thing is there, it's stuck, there's nothing you do with it, that's your vertical asymptote. If that exclusion went away in the course of simplifying, that's simply a hole in the graph or a place that the domain is undefined, okay? So that's the process for those. Now, the other thing that we did today to make sure you're comfortable, anytime you see a division, change it to a what? Multiplication. And then go name your exclusions. Don't name the exclusions as a division because you're going to flip that fraction. So change it to multiplication, then define your exclusions, and then all the problems work just like multiplication problems. Yes, question? When there are, when you look at it and there's no further, I hate to say no further simplification, when you've got it fully factored, and when you look at each factor, there's no simplification or duplication. So, when I've got 3x minus 2 divided by 3x minus 2, that's not fully simplified because that is 1, okay? So 4 minus x times 5 over x minus 4. So back to that 1. So you're still focused on that. So yeah, so what I look at here is, okay, when I look at that immediately, those are not the same thing, okay? But I look at it, they're very close, okay? So if this problem were -7 over 7, you guys would tell me, what is that? That's what? Not 1, but -1, right? This is -1, okay? You've got a negative and 7 over 7. So you look at this, -7 over 7, they're not identical, but if I look at that negative sign, then I say, okay, well, this is -1. So when I look at an x minus 4 and a 4 minus x, the only difference between those is a negative, okay? So to simplify something like this, you're going to have to write, this is -5 x minus 4 over x minus 4. And now recognize those things are 1. This answer is -5. So the reason I showed you that one is that that's a common one that shows up. x minus 1 over 1 minus x. You need to recognize the only difference between those two things is a negative. Okay? Question? So x minus 4 over x plus 6. Okay? Is there anything I can do there to simplify? First of all, are they fully factored? Was not meant to be a trick question. The answer is, yeah, those are fully factored. Okay, so the only thing, if they're fully factored, they either are identical or they're negatives away from each other. This is as far as this goes. Okay, there's no further simplification here. You can't do anything simplifying this. This is x minus 4 over x plus 6. Okay? X minus 2. That wouldn't be equal. So those are just two different things. This doesn't factor. If it were this, you'd have x squared, x minus 2, x plus 2. But these are not equivalent. Okay?